guys, and welcome to Functional Print Friday, and welcome back to my shop. So I'm not very good at standing these up. Let's find a way to store these. Let me show you where these normally live. So ever since getting this smaller lathe here in the shop, all the tooling that I've bought for it has just been kind of accumulating in a pile over here to the right side of it. And it's not a huge problem for the tool holders. These at least sit flat and kind of stay put. So, I mean, they have precision ground surfaces on them too. And even right there, I just knocked this one into the other one. So I want to solve that at some future point as well. But the bigger problem is this taper tooling that you just saw on the workbench. These are precision ground tapers that fit into the tailstock here on the lathe. And if you get any nicks on those, it raises up like an edge, and then it doesn't sit straight in there. So it doesn't lock into the taper. It'll actually damage the internal taper here on the tailstock. And as you can see, it's pretty much impossible to avoid damaging these the way that I'm storing them. So I do usually stand up the drill chuck at least. If I turn this so that the jaws are all the way back up in there, it's got kind of a nice flat face to stand up, but I've knocked that over already. And these two are just slamming into each other, and the ground carbide tips on this tooling as well. So it doesn't take a whole lot to raise up a small burr in one of these. So I want to design something to store these better. And since this tooling is smaller than the tooling on the larger lathe, I think we can actually do it right on the lathe. So just for comparison, in a previous video, we designed this in-drawer storage here for the taper tooling for my larger lathe, and that works out really great because if I spin 360 degrees, I'm basically right at the larger lathe, and these are quite large and heavy, so it's nice to have them here in a drawer. But on that smaller lathe, let's just see if we can figure out some way to store it right at the lathe. So here's what I'm thinking. We have all this kind of wasted space over here to the side of the backsplash. What if we could figure some way to hold these? So I guess we don't want to block the tailstock, and actually the lock for the tailstock, usually comes down kind of like right there. So we don't want to be down here, but we could start maybe like here, and then maybe do like a stair step of these. I'm pretty sure we can fit 3 in there. And I don't think, this is probably the widest of the 3. Let's see. Actually, the drill chuck might be a little bit wider. I'll measure that and see where we need to be, but I'm pretty sure we can fit 3 there. Now the complexity is, that is a bit of a weird shape. If I'm going to try and key onto this surface, because I don't want to modify this. I don't want to drill or cut the backsplash in any way, and I want this to be nice and secure. So ideally we design something that sort of locks in place on this or locks in place on this, and a combination of maybe down in this V here or up against the bottom of the flat of the bed. Because the tailstock rides on the V-way here. So nothing's over here on this flat. So we don't really need to worry about blocking that. We just need to make sure we keep the handle accessible. Yeah, so I think the first step is I'm going to try and get some measurements of sort of the side profile of the backsplash here. Let me see what I can figure out. I'll bring you guys back. Okay, I'm not particularly proud of this drawing, but I think I have enough information to keep going. This ended up being a lot harder than I anticipated to measure. I thought that we would find some similar angles or matching angles between at least the elements here that looked visually the same or similar. And in fact, every angle on here is different, and they don't seem to be any like even whole numbers. They're all over the place, at least the best I could measure. And I can hear you guys down in the comments saying, why not take a picture of this? It's a good idea. Unfortunately, I cannot get to where I would need to be to take a picture of the side of this straight on because my toolbox and workbench is just physically in the way. But oftentimes with weird shapes like this that are hard to measure, the easiest thing to do is just take a picture straight on from far enough away that you don't have a lot of distortion, and then get some of your measurements that are easier to take and then scale the drawing to that. I would have loved to do that in this case. Again, the position of it, it doesn't work out. So I think what I'm going to do, because I'm sure I'm not dead on all these measurements, because I really need the edge of the bed of the lathe and then the whole profile of the backsplash as well. I think I'm going to draw this in CAD and then print it out full scale. I think this should fit on the Neptune 4 Max. We'll just do it real thin and then actually put it up against the side and see how close we are and just adjust as needed, because otherwise, I don't think we're close enough to get something that actually keys onto this. So that's what I'm going to do. I'm going to go draw this in CAD. We'll print this out, and I'll bring you guys back. Oh, and before I forget, while we're on the topic of measurements, people keep asking me in the comments which digital calipers I use. And I've owned probably a dozen different pairs of digital calipers, and all of them have gone in the garbage with the exception of my Mitutoyo calipers and my eye gauging calipers. I own, I think, 3 different pairs of the Mitutoyo ones. These are my favorite. These are the ones you actually see on the channel the most because this is the pair that just happens to live here in my shop where I shoot most of the videos. I just went and grabbed this pair from my desk where I do most of my drawing. This is, I think, an 8. This is my 8-inch pair. The Mitutoyos are by far the nicest digital calipers. They do cost the most as well, but you get what you pay for. I mean, these are, not only do these work really well and are made really well, but they're like jewelry level measuring tools. They're gorgeous. They're incredibly well made. The eye gauging ones are also very good. I've never had these let me down. And the big difference between pretty much every other pair of digital calipers and the eye gauging and the Mitutoyo ones, the batteries last in these. I don't know what's different in the circuitry, but these actually turn off when they're not in use. I get probably on average 3 years out of the batteries on my Mitutoyo ones and these eye gauging ones. All the other calipers that I owned, even if they were in places where I otherwise didn't have a pair of digital calipers, they just went in the garbage because they got used infrequently enough that when I would go to use them, they were always dead. So I got tired of putting batteries in them and I threw them away. And here's the thing, it's not like I was going 6 months between using them. It seemed like the batteries only lasted at most maybe 3 months. If I didn't use them within 3 months, the battery was just dead. So yeah, in short, if you're shopping for digital calipers, in my opinion at least, the only brands worth buying are Mitutoyo and eye gauging. And when you're shopping for them, make sure that you're getting genuine ones. There's tons of knockoffs of the Mitutoyos, and I've even seen knockoffs of the eye gauging ones as well. I will put links in the description of this video to genuine versions of both of these. And if you don't like the prices of either one of these, I would say, honestly, wait. These are not prohibitively expensive. I want to say these were around like 60 bucks. The Mitutoyos are probably closer to 150. They're not cheap, but they are worth it. The one nice thing about these eye gauging ones as well is if you live in a country that is metric, this is not going to matter to you. But here in the US, like a lot of my drill bits, for example, are imperial. And I'll often use, the reason why this pair is in my shop is because I'll use this when I have a workbench full of drill bits from a project, putting them away if they're fractional, because they have a setting on here that actually shows you, if you're measuring an imperial, the nearest fractional size, which is super nice if you're stuck having both imperial and metric tooling. So that's something to keep in mind. I don't think that Mitutoyo sells a caliper that has a fractional option. So these will switch between metric, inch decimal, or inch fractional. Okay, so this finished, and I've already gone ahead and held it up here against the backsplash, and it's pretty close. I am off in a couple of different spots, and what I have done here, it's probably pretty hard to see because it's, I think, black marker on black PLA, but I've marked the adjustments that I need to make. Like I've got to come back 1 millimeter here. I've got, I think I was off the most here. Somehow I ended up way off on that angle. I've got to add 7 millimeters down here, -3 here, -1 there, +3 here, -4 here. So I'm going to go make those adjustments. I'm going to print another one of these, and hopefully we'll be there. All right, our updated one is complete. We're back over here at the workbench because I wanted to show you guys this. This is the same roll of filament, same settings, same printer. All I did was just adjust the dimensions, and you know, I mean, this one's not perfect either. This has some artifacts on it as well from extrusion, but look how bad this is. This is off the Neptune 4 Max. That printer frustrates me so much. And don't get me wrong, I'm thankful to have a machine that will print stuff this large, and having to do it 2 or 3 times to get a good print versus not being able to print that big, you know, I'm still keeping the machine. But let me know down in the comments if you guys are using something that will also do large format. The Neptune 4 Max is, I forget exactly how big it is. It's over 400 millimeters in X and Y. So it's the only machine that I can print really big stuff on. But I would love to switch to a different machine that has more consistency than this. So let me know what you guys are using. I mean, if nothing's out there, do I have to build my own machine? I don't know. Tell me down in the comments what you guys recommend. But let's go see if this fits. I'm gonna get some magnets. This PLA is really slippery on the painted surface, so I think if we pop some magnets on here, Yeah. Now I can kind of feel all the way around without it moving. Yeah, I'm still about 1 millimeter off right here, but that's okay. We're not doing anything down here, so that should be okay. Everything else, I think I'm right on. So, all right, I think we can now start actually designing our caddy or holder or whatever now that we want to key onto this, since we know where all these dimensions actually are in 3D. All right, and here is the initial design that I came up with for this. And actually, if I hide our design here, you can see how we used that side profile that we initially developed with those couple of test prints just to make sure we had all those measurements correct in this design. I took that and I just selectively extruded parts of it out. So I extruded out part of the bedways for the lathe, and I extruded out the sheet metal in the actual dimensions that it is. I mean, obviously it doesn't come all the way down to the other end of the lathe, but I extruded out enough that we can get an idea of how this is going to fit on here, including the detail of the folded over front section of the sheet metal where they formed that edge, because it is thicker there than the rest of the sheet metal. I probably did not need the detail up here at the top, but I do in the future want to design something that keys into this to hold the tool holders on this lathe as well. So I figured if I can use it in the future, I may as well just build that into it as well. So, all right, let me bring back our design. And you can see now, if I hide this just for a moment, you can see how there's a recess here in our design that is hopefully going to key into the side of the backsplash. If I bring the backsplash back, you can see we're not going to be able to slip it into place. My thought is that if we tip the front edge of this in like this, it should key into place here and then set this edge back again so it's kind of just stuck into position once we put it in place. And I think gravity will hold it in place once we set some tooling in there, but you know, we'll see when we actually have a test print in our hands. So I'm not going to do any more at this point. As I often say here on the channel, it's tempting to just keep tweaking this to be, kind of quote unquote the final design, but we don't even know if this is going to fit in place. And since the geometry is likely going to change as we tweak this to fit perfectly in place, there's just no point in trying to get all of the rest of this, rounded edges and stuff like that we want on the final design. The geometry of the Morse tapers, I actually found someone had modeled a Morse taper adapter. This is a Morse taper 2 on the inside and a Morse taper 3 on the outside. I brought that in just so we could kind of steal the geometry of that taper, and then I just basically cut that out of our design here, and I extended it so that these drop all the way through. My thinking there is if there's any chips or anything that ends up stuck on those tapers, or that they pick up, or for any reason, if chips even just fly off from machining and end up in these holes, I don't want to have a solid bottom, because eventually that stuff is going to pile up and is going to prevent these from seating into position. By having these holes go all the way through, that stuff should just drop all the way through and not end up getting stuck in there. I put a pocket up here in the front as well. We don't need it. It's just this design kind of looked silly having just a big flat surface here, and I don't want to have a hole. Like, I thought about having it extend even a little bit further and putting another hole up here for another piece of taper tooling, but I'm worried it's going to get in the way of the tailstock, which slides all the way down to the end of this bedway. So, all right, let's print this out and see if it actually fits. All right, our first test print is complete, and it came out pretty decent. This was printed on the Bambu Lab P1S. I did this at 0.2 millimeter layer height, so the surface finish on it is decent for 0.2 millimeter. We'll probably do the final one in a lower layer height just so it comes out really nice. I grabbed the Morse Taper 2 drill chuck here just to see how things fit. Yeah, there's no wobble there. That fits really nice. Actually, that might be a problem. I remember we ran into this when we did the taper tooling holders for the drawer as well. They were actually fitting too well and getting stuck in there. I, of course, conveniently forgot about that, even though that was like less than a year ago, I think. So, yeah, maybe I'll adjust the taper angle on this, or we'll do some custom geometry here at the top to try and keep these from locking. Because now that I think about it, in the drawer, they were going in at an angle, so at least we weren't fighting gravity. In this case, I'm probably going to do this with these, like kind of walk up and set them in there and let them fall in place. And yeah, actually yeah. I mean, I can get it out, but that was stuck in there pretty hard. So, all right, we'll have to think about that. Let's let's see how this actually fits on the lathe and how it looks. That's close. I don't know if you guys can see from the camera angle. It's hard to get the camera in a good spot because of where the workbench is here, but it's I'm probably, it seems to want to pull this way a little bit, and I am maybe 7 or 8 millimeters from it actually meeting up here at the top. So we're probably, you know what, if I push harder, I'll probably make a mark on there. Yeah. It's kind of scrunching this corner down here. So I think that's where the issue is. Maybe I'll lower this face a little bit and bring this face back just to make sure we have clearance, but it shouldn't stop us from trying it. All right, we're too close there. I often keep the tailstock all the way over here at the edge of the bed, and if we do that, I then can't, I have to always remember to push the tailstock forward before I try and take out whatever tool I keep here. So we'll need to move that one back a little bit, and now that I'm seeing this, I think we do actually have room to space these, that we don't have to try and just have a small one here. Like this is, we have the clearance here, but if I move this back, that's going to tighten up against this face. And we can't put, like I can't put this one here. It kind of looks like I can, but it's hitting. It's not going all the way in. This face is hitting back here. And same thing here. I can't put this one here. This one fits here now, but it won't when we slide that back. So I think we have enough room here that if we move the position of all 3 of these back a little bit, so we shift this one back, and then we shift each one of these back even further, we'll still be within sort of the space here of the side of the lathe, but they won't be, well, it won't be blocking the handle for the tailstock, and they won't be, you know, I won't have to make sure that I put them in a specific order. If I switch out to different tooling in the future, I'm not limited by what I can put in these slots. So when I'm designing something like this, the number one thing that I'm thinking about is user experience. I imagine myself standing here using this, and I think, what do I want the experience to be like? And that will help you catch stuff like this. I can't even bring this all the way back. This now actually hits this, so that's no good. I think about, I'm going to be standing here, I'm going to grab these. So even though gravity is holding this in place, and I could take 2 hands, I could hold this one and lift this out, but that's not a good user experience. I want to just be able to walk up to this and grab one. So we're going to have to think about how we keep this from coming forward, because even if this is fitting, if I push this back in place, that's not really locked. Particularly if I grab the top one, this is still going to swing forward. Yeah, again, gravity's keeping it in place. It's not going to go anywhere, but the user experience of grabbing a tool out of here is not good. It requires 2 hands. So we have to fix that. And I don't want to have to put these back in the exact same order for everything to fit. All right, so I think the next step is to come up with a V2 that at least has these in the right position. I'm probably not going to figure out how I want to lock this in place yet, because that might change if we need to shift the design again. So, all right, I'm going to go work on a V2, and I'll bring you guys back. All right, and our version 2 print is complete, and I will show you guys the final design for this. We're not there yet, but we're getting close. So if I stand these 2 up next to each other, you can see the changes that we've made. You can see we've moved this back substantially, and the same thing, we've shifted all these back as well. And I think we're still be well within the bounds of sort of the side of the backsplash. So let's go give this a shot and see how things line up. Oh, I also added some bumps or nibs or whatever you want to call it here at the top of the taper slots as well, to try and keep the taper tooling from seating in the taper here. I left the taper angle alone. I'm hoping that just with sort of that added geometry, that it keeps it from actually seating down in the taper. It limits the contact surface between the 2, so we'll see how that works. All right, that fits good. Yeah, the rattle that you're hearing is just, we could probably narrow that slot a little bit, but it is seating all the way up against that angle. And yeah, that looks good. See how the stuff actually fits. Oh, that actually looks much better. And they don't have to go back in this order now. We can now put them wherever we want. I'll probably still try and keep the smallest one down here in the bottom, because that gives us the most clearance for this handle. I think even if we put this one down here now, yeah, that clears. There's probably about 10 millimeters there. So at least it doesn't hit. It makes it a little hard to grab it, but then again, I'm probably not often locking the tailstock all the way back here. So that's good. And they don't seat as solidly in the tapers as they did before. And we've only introduced a tiny amount of wobble. So I might tweak that a little further. They still stick in there more than I would like. We're not going to be able to completely eliminate that because, I mean, at the end of the day, it is a taper that we're dropping into that slot. So, but I think we can do better. And, let's try a little pocket down here. I don't know what we're actually going to put in there. I guess we could have the wrench for the drill chuck there. And we still need to figure out a way to retain this as well. Now that these are not seating in here as much, it's not pulling as much. But yeah, you see it's still lifting away. So I want something that locks this in place so that I can just reach over here with one hand, grab, and know that whatever force I use to lift it out, that this is going to stay in place. That might be as simple as maybe just adding something here in the back. I don't want to screw into this. We could easily just add like a recessed hole here for a bolt to go through, and that would absolutely lock it in place. But I don't want to modify the backsplash if we don't have to. If we take this out of the way here. So this has to lift like this. It has to lift in sort of this almost arc motion to come out of here. So if this can't come at all this way, that might be enough. So maybe we just add like a piece here in the back. I know it's tough for you guys to see, and I can't get the camera back here. But if we add something into the back here that keeps this from swinging forward, I think that does it. I find myself already naturally standing here and just pushing on this with my thumb, like grabbing here. Yeah, if this can't move forward, then it's absolutely locked in place because we're already pinned up against the bottom of the bed here. Like I can't, no matter how hard I grab there, it's not going anywhere. It's just this top. We got to find a way to lock that top in. So, all right, I want to adjust the geometry at the top of these slots just a little bit more, and I want to find a way to lock this at the top. And I think we could take a little bit off of the groove here for the side of the backsplash. So I'm going to go make those changes, and I'll bring you guys back. All right, and here's a quick peek at my design space for what I'm hoping is the final design on this. So this now has all of the elements rounded over and sort of finished out the way that I actually want to see this in use. And I added a locking piece back here as well. So if I pull this back off, you guys are probably wondering why I've made this so complex versus just having two holes here on the back and just a flat piece that locks this against. And my thinking is, this is going to be blind. We're not going to be able to see this, at least the way that my lathe sits on the workbench. And this is a benchtop lathe, so it's probably going to be the case for anybody. I can't stick my head back there to put this in place. So I think by having this keyed to fit into there, we should be able to blindly put this in place and then blindly put the bolts in to hold this as well. And you notice there's a bit of an interference here between the geometry of this and the back of our backsplash. My thinking is that we'll put this bolt in first, and we'll put this bolt in, and if this one doesn't tighten in all the way, that's fine. I want this to basically be a tight squeeze, that we're pulling the face here that runs down the front at an angle against the front face of the backsplash, and this face then snugly holds everything in place. Like if this works the way I'm thinking, this should securely lock it in place with no wiggle room at all. So, all right, I'm gonna print this out, and I'll print this piece out separately, and I'll bring you guys back. All right, and what I hope is our final version is complete. And not only did I do this in a different color, I did this in the dark gray from Bamboo Lab. As I use up my other colored filament, which is mostly Hatchbox that I've bought over the years, I've been buying the colored stuff from Bamboo just because it is convenient that it does set the color automatically in the AMS. But this looks really nice. I'll link to this down in the description of the video as well. I'm pretty sure this is dark gray. I'll double check before I put the link in. But I printed this in 0.12 millimeter layer height as well, and it just looks really, really crisp and clean. You know, 0.2 millimeter does print really fast, but if you're not in a hurry, if you've never done it, print in like 0.12 in the high quality setting. It comes out so gorgeous. This took, I think, 11 and a half hours, so it wasn't fast, but you know, I had overnight to print it, so not a big deal. All right, let's see our fitment here on the back. Ooh, that's perfect. So I did 0.1 millimeter clearance. I found as a general rule of thumb, if you're trying to figure out how much space to leave yourself for parts to fit together nicely, match the clearance to your layer height. I knew I was going to print this at 0.12, so I used 0.1 as clearance, and that is just like, look at that. Like it's really fits on there nice. Like I'm pushing it back in, like this face against this face, and it is flush up here in the front. I can't even feel that step. And same thing for our depth here. Again, the reason that I did this so complex like this with the 45-degree angles is we're going to be reaching around the back of the machine to put this in place. So the fact that this keys in like that, and then we have nice, you know, large holes here for our bolts to go in, should make it that we can do this completely blind. That's why we have the overkill geometry there. All right, I grabbed the M5 taps that I have, and I have just 2 loose ones here and then a set of 3. I'll usually buy these sets of 3s and then just keep extras around in case I break something for like the standard taps. But there are different taps. Like if we look at this set of 3, there is a starting tap, a regular tap, and then a bottoming tap. So I'll usually start with the starting tap, and then I'll just go right to the bottoming tap, particularly in plastic. The nice thing about the bottoming tap is you get much closer to, well, the bottom of the hole to put threads in. If you're trying to thread a hole all the way down with a starting tap, you're never going to get there. These, like this tap, it's not cutting a full thread till probably about right there where my fingernail is. Before that, it's either cutting no threads at all, or it's cutting a tapered thread. So particularly if you don't have a certain size taps, don't buy just the regular tap, buy the set of 3. It doesn't cost that much more. All right, and these are M5 by 16 millimeter long bolts. These should be just right. And I'm doing test fit here because, again, we're doing this blind behind the machine, so I want to make sure everything fits and feels nice and smooth before we actually go try and put this in. Yep, fits good, although, you know, seeing this, I wish we'd gone a little bit thicker with that. And I know if I don't do it now, I'm never going to change it. So I think I'm actually going to go tweak this design really quick and just make this a little bit beefier. Be right back. All right, that was a really quick print. At least this is like 15 minutes to print this out. This one probably would have been plenty strong enough, but that is definitely going to be strong enough. All right, let's go install it. So this aspect of the design is again about that user experience. In this case, it's the user experience of actually installing it on the machine because I can't get back here. You know, there's no way I could even fit my head back here. So by designing it like this, yeah, look at that. There's only one way it fits. It just keys itself right in place. And there's big enough holes for these bolts to go in to get started that I can do that blind as well. Let me grab the other one. Oh, that locks against there really nice. I think between tightening up our groove here that goes against the sheet metal, or that keys against this edge, and then having this lock, like this feels really, really nice on here now. Like I can, man, there's a tiny bit of wobble with a little bit of paper thin gap we have up there, but otherwise that thing is, I could probably lift the lathe up with this. Oh yeah. Yeah, see, that's the experience I wanted. I wanted to be able to reach over one hand, whatever force is needed to pull this out. Like I don't have to think about it. Just lift it right out. And I can put these in whatever order I want as well now. Even just letting gravity drop them in, because now I can pull on them real hard. Well, guys, I'm really happy with how this came out. I think it would also look really good if I could find a filament that matched this color blue. What I was thinking with the gray was kind of trying to match the color of the cast iron on the machine, and it's not a perfect match for that. It does, I think, complement it well, and you know, the appearance is secondary to function, but I do like things to look like they belong as well. And I think that really does genuinely look good on there. So let me know down in the comments, is there anything you would have done differently on this? Do you have any questions about the build? Is there anything you could think of that would make it even better? And as always, guys, thanks for hanging out in the shop with me for this week's design and build. This was a lot of fun. Hopefully you guys enjoyed it as well. If you want to make one of these for your own machine, the design for this, the STL, as well as everything we do here on the channel, I give away completely for free for your own personal use. All those STLs are on my site, fpfdesigns.com, and I will link that down in the description of this video. If you don't have a 3D printer and you're still interested in getting one of these, still check the description of this video. If I get enough demand, oftentimes I'll make stuff like this available for sale. So check the video description. If you don't see anything down there, leave me a comment, or even better, reach out to me on the contact page on my site, fpfdesigns.com. And guys, if this is your first time here on the channel, this is all we do. It's all functional prints. A lot of stuff out here in the shop, but I do stuff around the house or out in the yard as well. So if you like that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.